Okay, in this chapter, sorry about that. In this chapter, 5.7, we're supposed to write zeros in the dividend. And once in a while we need to do that. Let me show you a problem real quick and then I'll explain why. Say we have 45 and 8 tenths, 45.8, divided by 4. So that's rewritten. 4 goes into 45.8. And we'll go ahead and change colors, move our decimal to the top. 4 goes into 4 one times. 1 times 4 is 4. Subtract. 4 take away 4 is 0. We can write the 0 or we don't have to. Bring down the 5. See, this is 05, but it's the same as 5. 4 goes into 5 one time. So 4 goes into 45 11 times. You can see how that works. 1 times 4 is 4. We subtract. That leaves 1. And we're going to bring down this 8. Okay, so 4 goes into 18 4 times, because 4 times 4 is 16. Now that leaves us with a remainder of 2. 18 take away 16 is 2. And we often would write a remainder, but once we start using decimals in our long division problems, we're no longer able to write a remainder. So I'm going to add a 0 on here. And this is the part we're talking about. Writing zeros in the dividend, we have to write a 0 in here in order to continue on. And we just changed 8 tenths into 80 hundredths. So what I want to show you, or what I want you to see, is that this is 45 and this was 45 and 8 tenths. Now it's 45 and 80 hundredths divided by 4. So really the important part of the problem is this 8 tenths and 80 hundredths, this point after the decimal. And we have to compare these two. If I write 8 tenths out as a fraction, it looks like this. This one, 80 hundredths, looks like this. And I want to know if they're the same. Well, let me show you a little trick. I'm going to multiply by 1. Whenever we multiply by 1, we get the same answer, correct? Well, I'm actually going to kind of trick you. I'm going to multiply by 10 tenths. And 10 tenths is the same as 1. 10 tenths is 1, so when I multiply 8 times 10, I get 80. When I multiply 10 times 10, I get 100. And really all I did was multiply by the number 1. Okay, so 8 tenths is the same as 80 hundredths. And you can kind of see it mathematically by just knowing that we just multiplied by 1 to change that. Whenever you multiply by 1, you get the same answer. This answer looks different. 80 hundredths looks different than 8 tenths, but they are actually the same thing. If I were to take my tenth sticks and count out 8 of these tenth sticks, I'd have 8 tenths. But if I look at them and I cut each one into 10 little hundredths pieces, then you can see I'd have 10, and then I'm not going to draw them like that, 20, 30, 40, 50, 60, 70, 80. This is 8 tenths. This is graphically what 8 tenths or 80 hundredths looks like. Each one of these sticks has 10 hundredths in it. You know that because we've been working with this. So there's 10, 20, 30, 40, 50, 60, 70, 80, or just 1, 2, 3, 4, 5, 6, 7, 8. So it's either 8 tenths or it's 80 hundredths. This is the graphical representation using a picture, and this is the mathematical representation using numbers multiplying by 1. Okay, and I like the math, but some people understand the pictures better. I think we need both to really move forward. So what you're supposed to understand from today's lesson is that adding a 0 onto the end of the fraction doesn't change the fraction any. It's still equal. It's still equivalent. We're going to bring down this 0 now. And now 4 goes into 20. See, before we had a 2, and that's remainder because it's smaller than 4. But when we add a 0, instead of 2 tenths, now we have 20 hundredths, which is the same. 2 tenths is equal to 20 hundredths, so I just added a 0, brought it down. 4 goes into 20 5 times. 5 times 4 is 20. And so I have 0 remainder, 0 left, and I can stop. My quotient is 11 and 45 hundredths. 11 and 45 hundredths is how many times, or is what you get when you divide 45 and 8/10 into 4 equal sections. And that's the news. Let me show you real quick just an example of the decimal when it changes. So we have like 0.3. So this is 3/10. If I go like this is 30 hundredths. And if I add another 0, it's 300 thousandths. But it really doesn't change at all. This is 3/10. This is 30 hundredths. Oop, I wrote thousandths. There we go. 30 hundredths. And this is 300 thousandths. But they're all exactly the same. They're all equivalent. If I do some other things, like if I write it like this is not equivalent because this is not 30 hundredths. This is not 3/10. This is 3 hundredths. And this cannot be the same as 3/10. 3/10 is not the same as 3 hundredths. So sometimes we add our zeros in the wrong places and it causes us trouble. And I needed to make sure you saw that. You add the 0 after. This is the number with value. 3 has value. 0 doesn't really have value, but sometimes it holds a place. So we put it here in the tenths place, and it's holding that place, and we put the 3 here. It's reversing them. It doesn't work. This does not match 3/10. Okay, now that you've seen all that, I think I can just show you maybe one more problem, and then you can get to it. Maybe 2 more problems. So 1.23 divided by 0.06. All right, so this one can be rewritten as long division. 0.06 goes into 1 and 23 hundredths. Let's make sure I write a 3. Okay, now what I have to remember from the previous lesson, 5.6, is that it's not as fun to do the division with a decimal in the divisor. So I'm going to move that decimal over twice and move this decimal over twice. We learned last time that this is an okay way to do it. And I'm going to rewrite the problem as 6 into 123. Now this doesn't show a decimal. It doesn't show a decimal, but remember, and I'm going to show you in a second, there is one here. There's a decimal at the end. It's kind of like 123.0 is the same as 123. But I'm just going to leave it out for now because I want you to kind of recognize what happens when you run into it. 6 doesn't go into 1 evenly, but it does go into 12 2 times. 2 times 6 is 12. 12 take away 12 is 0. And I'm going to bring down my 3. And this looks weird because it doesn't work. 6 doesn't go into 3. 3 is smaller than 6. I might think that I have a remainder, but really what I need to do is I need to use that 0 that we talked about as a placeholder. This holds my place in the ones place. 0 times, and you can skip this step or you can use it. I'm going to show you this next step is something you could just skip over if you want. 0 times 6 is 0. 3 take away 0 is 3. So notice how I still have 3. I could have just gone ahead and moved forward. Now, I can't use a remainder of 3, so I have to put in that decimal that I told you about and that 0. So 123.0 is the same as 123. But now I put my decimal up on top of the division bar, and I bring down my 0. And now 6 does go into 30. It didn't go into 3, but it does go into 30 5 times. So 5 times 6 is 30. And there is nothing left when I subtract. And really, guys and girls, I didn't even really have to do this. If I know that 5 goes into 6 evenly and that I'm done with my problem, I can actually, I can actually just stop right there. But it doesn't hurt to show the work and to go ahead and write 5 times 6 is 30. It doesn't hurt to do this. 30 take away 30 is 0, because this kind of shows that you're at the end. It kind of shows that you're at the end when you get down to the 0 here. But it's also okay to just skip that and leave it alone. Okay, one more. Let's see, we started with like purple color. I don't know, maybe it was that color. 10 divided by 0.8. 10 divided by 8/10. Okay, rewrite this as a division problem. 0 and 8/10 goes into 10. And then again, this is something that the reason I'm showing you this is because you have to understand what happens when you need to move that decimal. This decimal gets moved over one place. And where's the decimal? Well, I have to remember that 10 is really the same as 10.0. And if I add that decimal on, then I can also move it over one. So now it's just 8 goes into, not 10.0. I've moved that decimal over, and it's 8 goes into 100. Okay, now I might need to add, in fact, I'm sure I'm going to have to. I'm sure I'm going to have to add a 0 on the end of the decimal because I already know what happens. I know that 8 goes into 1,000. I know that 8 doesn't go into 100. But you might not know that yet. So you just take my word for it. 8 doesn't go into 1, but it does go into 10 one time. 1 times 8 is 8. 10 take away 8 is 2. Bring down the 0. Now I have 20. 8 goes into 20 twice. 2 times 8 is 16. Subtract. 20 take away 16 is 4. Now if you don't like that, you can borrow or rename, change this to a 1, make that a 10. 10 take away 6 is 4, and 1 take away 1 is 0. Okay. I did the same thing, just 20 take away 16. And it saves me from having this mess here, this kind of a mess when I have all of these little slashes and rewrites, and sometimes it's hard to read. Bring down this 4 and say now I'm in the tenths place. I'm on the other side of the decimal. 4 is what I have left, and usually that would be a remainder, but this time we're going to go ahead and use decimal forms. So 8 goes into 40 5 times. 5 times 8 is 40, and we're done. End. 12.5 is how many times 8 goes into 10. Sorry, not 8, 0.8. It's how many times 8 goes in 100, and it's how many times 0.8 goes into 10. So 12.5 would be a way to write our answer like that, and up here we might say 20.5 because that was our quotient, answer to a division problem. Okay, that's all I have for you. This should be relatively normal for you. You guys have done long division before. This adds decimals. You have to remember to put your 0 in. And sometimes you have to put zeros in more than once. This problem could go on and on and on. Oh, actually, let me show you one that does. Say I have something crazy like 1 divided by 3. Okay, this is just the fraction 1/3. Okay, but it's really 1 divided by 3. If I go ahead and rewrite that as 3 goes into 1, and you might say, Mr. Armstrong, you're crazy. 3 can't go into 1 because 1 is smaller than 3. Well, I'm not crazy. It does go into it. It just doesn't go into it a whole time. Okay, it goes into it less than once. Obviously it does. So 3 goes into 1 0 times. 0 times 3, we can't do that. So we're gonna say, well, what about 3 goes into 10? 3 goes into 10 3 times. 3 times 3 is 9. 10. See, I'm not focusing on this decimal right here. I put it up on the line. I don't have to worry about it anymore. So I'm just going to imagine this is 10 when it's really 1 and 0 tenths. 10 take away 9. 10 tenths take away 9 tenths equals 1 tenth. All right? So there we go. Oh, look, I'm kind of done, but I don't want to have that remainder, so I have to add another 0 and bring it down. And then I notice that 3 goes into 10. Oh, 3 times 3. 3 times 3 is 9. 10 take away 9 is 1. Are you guys starting to sense a pattern? I think you probably are. Extend my division bar, add another 0. I've got 10 again. Notice I had 10, 9, 10, 9, 10. And notice I have 3, 3. I'm going to have 3 again. 3 times 3 is 9. It's going to keep going forever. This is a repeating decimal that never stops. Okay? And the fraction 1/3 does this. The way that you can write the quotient is 0.3 with a bar over it. That means that this 3 repeats forever. Okay? That's all you can do. If you put it in your calculator, it's just going to show, if you put in 1 divided by 3, it's going to show 0.3, and it's going to just keep writing 3's until it gets to the end of the screen, unless you have a special calculator that does something else. And when it runs out of room, it's just going to stop. But it really goes on forever and ever and ever. You'll never find the end to it because it just keeps repeating. All right, so that's kind of an extra lesson. See you later.